Okay, so let's do a couple of examples where we're going to find the represent these points on a unit circle in terms of sine and cosine. Okay, now that we know that we can represent x and y as functions of sine, cosine and sine, so let's do that here. So here, if we look at this point here, we've got 1/2, comma, 3, root 3 over 2. So, how do we represent this in terms of sine and cosine? Well, we have to understand that since we're dealing with a unit circle, we know that x equals what? Cosine theta, and y equals sine theta. So that's what we have to remember. Okay? Now, now, incidentally, we can go to a general formula, but we'll cover that later when we talk about polar coordinates. But there's a more general formula for x and y, but we'll get to that later. But for the purposes of what we want to do here, just realize that we can represent x and y as just cosine theta and sine theta, respectively. And so let's take this point here. We know that this is x comma y, so we know that what? X is equal to 1/2 and y is equal to root 3 over 2. Okay, now that's it, right? We're done. That's all they want us to do. They want us to find cosine theta and sine theta. And so all we're doing is just using the fact that, hey, the way x and y are defined, it's that easy. Okay? Now, if they want us to find theta, which we'll get to, but if we wanted to find what theta is, then we have to understand, hey, based on the unit circle, we should know what is this, right? This is cosine theta, which is what? Adjacent over hypotenuse. What basic triangle has that as adjacent over hypotenuse? If you remember from the previous videos, you might know this, right? Or you can figure this out. Same thing here goes here. What triangle, right? What angle has what sine opposite over hypotenuse, where we get square root of 3 over 2? Or better yet, maybe this will help you. Okay? This actually is the same as 1 over 2 root 3. Oh, hold on a second. No, I take that back. I take that back. We don't want to do that. Nope, that's wrong. So this should give it to you right here. So again, opposite over hypotenuse. I'm not going to tell you the answer, but figure it out. We'll get to there. If you were paying attention to the previous videos, then this will definitely look familiar and you'll be able to figure it out. Okay, now what about the next one? Well, let's look at this point here. Okay, now again, we want to represent this point in terms of sine theta and cosine theta. Again, real easy. All you have to do is realize that x is cosine theta and y is sine theta, and that's it. So in this case, let's call this point P, right? So for point P, this is true, and let's call this point Q. And so for point Q, what do we have? We get what? Okay, and this will be negative, right? This is negative. And then y is positive, square root 2 over 2. Now this is also going to give you a particular angle, right? And again, these two would, the other form that it looks like is going to be this, 2 over root 2. Or no, sorry. Okay, but remember, we don't usually leave it. We don't leave it like this because we don't want square roots in the denominator. So we multiply the top and the bottom by the square root of 2. Remember, that's called rationalizing the denominator. So that's where this form comes from. Okay. So that's how you would represent point Q in terms of cosine and sine, theta. Have a great day.